Assalamu alaikum and good day, students. This video lecture is a continuation of the discussion on normal probability distribution, and this will be your last video lecture for the chapter Elementary Statistics. By the way, I am Najma Pendiaman, a faculty member from the Mathematics Department, College of Natural Sciences and Mathematics, Mindanao State University Main Campus, Marawi City, your video lecturer for today. Once again, our topic is about normal probability distribution. And if you can recall from the previous video lecture discussed by Professor Daniel Sanson, he has mentioned the empirical rule for computing probabilities from a normally distributed data. So let us give an example here before we continue with what we will actually discuss in this video lecture. We have here an example. The scores of the GEC104 students in their final exams are approximately normally distributed with a mean of 80 and a standard deviation of 5. The question goes like this. If you randomly select a GEC104 student, what is the probability that his score in the final exam is between 75 and 85? Note that in the normal curve, where the population mean is 80 and the standard deviation is 5, 75 is 80 minus the standard deviation, which is 5, and 85 is 80 plus 1 standard deviation, which is 5. So, by empirical rule, the probability that the score of a randomly selected GEC104 student falls between 75 and 85 or falls within 1 standard deviation away from the mean is 68.27%, or that is 0.6827. Another question, what is the probability that his score in the final exam is between 70 and 90? Now, 70 is 2 standard deviations below the mean, and 90 is 2 standard deviations above the mean. So, by empirical rule, the probability that the value of a random variable falls within 2 standard deviations away from the mean is 95.45%, or that is 0.9545. And lastly, what is the probability that his score in the final exam is between 65 and 95? Again, 65 right here is 3 standard deviations away from the mean. And 95 is 3 standard deviations above the mean. So now, by empirical rule again, the probability that the value of a random variable falls within 3 standard deviations away from the mean is equal to 99.73%, or 0.9973. Now, the focus of this video lecture is on computing probabilities where the concerned values, for example, these values here, are not exactly 1, 2, or 3 standard deviations away from the mean. For those cases, we cannot use the empirical rule, so that's why we have this video lecture discussing cases like this. For example, we have what is the probability that the score falls between 73 and 83, or what if we are asked to compute the probability that the score falls below 73, or what if we are asked about the probability that the score is 83 or above. We are going to use Excel or Microsoft Excel to compute these probabilities, or you may use your phones by using this application, WPS Office, if you don't have Excel in your phones. Let's start with the probability that his score in the final exam is 73 or lower. So we have this graph. So we are concerned about the probability that his score in the final exam is 73 or lower. So the probability is actually equal to this area, this shaded area here. So this is what we are going to compute in Microsoft Excel. So from Microsoft Excel, we can use formulas. We can click more functions and then statistical and then look for normal distribution. That is norm.dist, short for normal distribution. Okay, so from normal distribution, we have to input four values here. The value of x. Ang x natin, di ba, since we are computing for the probability that x is less than 73, we are going to input 73 here. And then the mean of the distribution is 80 and the standard deviation is 5. For the cumulative, we are going to input through here. Now, the resulting value is this one. So 0.0808 if you're going to round this off to four decimal digits. Okay? Or, so we have it here. Or, we can directly input our formula here. So our formula is equal norm.dist. This is short again for normal distribution. And then, open parenthesis, we will write x. So, ang input natin for x is 73. So, this value here, yan yung input natin for x. And then, the mean of the distribution is 80. The standard deviation is 5. And then, lastly, for cumulative, we will write true. So, press enter, we get the same value. So, this is now the probability that the score of the randomly selected GEC104 student is less than 73. So the probability is 0.0808. Next question, what is the probability that his score in the final exam is 83 or higher? We are now looking for the area to the right of 83. So note that if we are going to use the formula that we have used earlier, the resulting value will be the area to the left of 83. But we are looking for the area to the right of 83. And that is very simple. We can compute that very easily because we know that this curve here, the total area under this curve is equal to 1. So if we can compute this value here to the left of 83, just subtract it from 1 and then the difference will be the area to the right of 83. Again, using Excel, we will compute first the probability that x is less than 83. Kasi ito yung my formula sa Excel. So you have equal norm.dist. Again, stands for normal distribution. And we are looking for the area to the left of 83. Ang mean ng distribution is 80. The standard deviation is 5. And again, true. Press enter and we get 7.72.575. Now, our concern is not the probability that x is less than 83, but the probability that x is greater than 83. Okay, now, again, to compute for this value, we will just subtract this value from 1. So we have equals 1 minus, just click this cell and then press enter. So we get 0.27425. The probability that x is greater than 83 is just 0.2743 by using Microsoft Excel. Okay, now let's move to the question, what is the probability that his score in the final exam is between 73 and 83? So we have this graph of this problem. So now we are looking for the probability that his score is between 73 and 83, or equivalently, we are looking for this area here, this shaded area. So note that, again, using Microsoft Excel, we can compute for the area to the left of 73. We can also compute the area to the left of 83. So to compute this shaded region, we have to compute the area to the left of 83. So all the area to the left of 83 minus the area to the left of 73. So we have to subtract this region because this is not part of the shaded region. So pag subtract natin yan, ang matitira na lang is the area between 73 and 83. So using Microsoft Excel, we have the formula is equal to the area to the left of 83 minus the area to the left of 73. So since we have completed these two areas earlier, or these probabilities earlier, we just have to subtract, then press enter. We have the probability that x is between 73 and 83. If we round this off, we have 0.645. Another type of question, what is the highest score of the 10% of the students with lowest scores? Or in other terms, what is the highest score of the bottom 10% of the students? We are looking for the value of A, where the probability that the score is less than A is equal to 10% or 0.1. So, given ang probability na 0.1, ang hahanapin natin is yung value ng A. We can actually use Excel to compute this value. So, using Excel, we are going to use the command equals norm.in. Instead of using norm.dist for normal distribution, we're going to use in for inverse. Since given ang probability, yung A yung hinahanap natin yung value ng 0.1 ang probability, the mean of the distribution is 80, and the standard deviation is again 5. So, the value of A here is 73. Another question, what is the lowest score of the top 10% of the students? So, the highest 10% or the top 10% of the students, what is their lowest possible score? Note that if this shaded region here is 10%, it means the remaining unshaded region here is 90%. So now, we are looking for the value of B, where probability that X is greater than B is 10%, or equivalently, the probability that X is less than B is 90%. And since in the Microsoft Excel, ang pwede natin gamitan ng command doon na makakompute tayo directly is probability that X is less than B is equal to 90% or 0.9, ito yung magagamit natin sa Microsoft Excel. So instead of 10% para sa greater than, less than yung gagamitin natin. Tapos 90%. Using Excel, we have the probability that X is less than B is equal to 0.9. And now, we are looking for the value of B. This is equal to the same command na ginamit natin dito sa taas. So, it is equal to norm for normal distribution, pero inverse. Norm.inv, and then probability is 0.9. The mean is 80, and then standard deviation is 5. Then press enter, we get this value, 86.4. Note that kung i-compute natin yung probability that X is greater than 86.4, we will get 0.1003 or approximately 10%. Okay, we have here another problem. The length of human pregnancies from contraception to birth varies according to a distribution that is approximately normal with mean 266 days and standard deviation of 16 days. Now we have the first question. Between what values do the lengths of the middle 90% of all pregnancies fall? So, anong values daw? Say what values A and B wherein 90% of all pregnancies fall between these two values. And when we say middle 90%, it means the area to the left of A and the area to the right of B are equal. Another question, how short are the shortest 5% of all pregnancies? So, we're looking for the value of A. such that the shortest 5% of all pregnancies are less than A. And last question, how long do the longest 5% last? How many days ang longest 5% human pregnancies? 5% yan siya. We are looking for the value of B here. Okay, let's start with the second question. So how short are the shortest 5% of all pregnancies? So we are asked about the value of A such that the probability that X is less than A is 5%. Or in other words, we are looking for the value of A such that the area to the left of A is 0.05. So now we can use Microsoft Excel to compute for this value. We are going to use the inverse. The formula is equals norm dot inverse. So ang probability is 0.05. The mean of the distribution is 266 days. And the standard deviation is 16 days. And we get 239.68. Yung A natin is actually 239.68. And this means that the shortest 5% of all pregnancies are 239 days or shorter, even shorter. So this answers our second question. So the third question is, how long did the longest 5% last? What is the value of B such that the probability that X is greater than B is 0.05? Or equivalently, we look for B such that the probability that X is less than B is 95%. Kasi kung ang nasa area na nasa right side niya is 0.05, it means the area to its left is 0.95. Itong less than B, ito siya yung pwede natin gamitan ng Microsoft Excel. So we will use the probability 0.95. Using Microsoft Excel, equal sign, then norm dot inverse again, open parenthesis, the probability is 0.95. Then the mean is 266 days and the standard deviation is 16 days. Then press enter. Then we have 292.32. This point here is actually 292.32. This means that the longest 5% of the human pregnancies last for 292 days or even longer. Now, for the first question, babalikan natin kasi inuna natin yung second and third questions. So, for the first question, between what values do the lengths of the middle 90% of all pregnancies fall? So, since middle 90% yan, ibig sabihin, yung value dito na, area dito sa left side, tsaka yung nasa right side, dapat equal sila. So, if this point here is A and this point here is B, the probability that X is less than A should be equal to the probability that X is greater than B. So, ngayon, the area to the left of A plus the area between A and B plus the area to the right of B must be equal to 1. And now, given that this middle area here is 90% or 0.9, then we subtract 0.9 from both sides of the equation. So, yung right side magiging 1 minus 0.9 which is 0.1. Ngayon, if two equal values, their sum is 0.1, then each of them must be equal to 0.05. So it means this area here is 0.05 and this area to the right here is 0.05. And now we have computed earlier that the value of A such that the probability that X is less than A is 0.05 is 239.68. And we also have computed that the value of B, where the probability that X is greater than B is 0.05, is 292.32. So we know that ang A natin is 239.68, ang B natin is 292.32. It means that the middle 90% of all pregnancies or human pregnancies fall between 239.68 to 292.32 days long. Okay, we have another problem here. This is about scores for an IQ test. So the scale of scores for an IQ test are approximately normal with mean 100 and standard deviation 15. So the organization Mensa, which calls itself the High IQ Society, requires a score of 130 or higher. So what percent of adults would qualify for membership? We are looking for the percentage belonging to this portion or the probability of acquiring an IQ test score of 130 or higher. Since we are computing for the probability that x is greater than or equal to 130, or that's actually the same with computing the probability that x is greater than 130, and we cannot compute this directly from Microsoft Excel. What we can compute from there is the area to the left side of 130. We have to subtract the area to the left from 1 so that we can obtain the area to the right of 130. So using Microsoft Excel, we are going to look first for the probability that x is less than 130, or that is the area to the left side of 130. Since we are looking for the area or the probability, we are going to use the command equals norm.dist, short for normal distribution. And then we have, since we are looking for the area to the left of 130, the first entry here is 130. The mean IQ test score is 100, and the standard deviation is 15, and then we have true. So the area to the left of 130 is 0.9772. How about the area to the right of 130? So the probability that x is greater than 130 is equal to 1 minus the area to the left. So we get 0.02275. If we round it off to 4 decimal digits, we get the probability 0.0228. Or if we convert that to percentage, we have 2.28%. So since the question here is what percent of adults would qualify for membership, the answer is only 2.28% of the adults would qualify for membership to this organization called Mensa, which calls itself the High IQ Society. So that's all for the discussions for this video lecture. So here are the commands that are used in Excel and their counterparts in WPS Office. So ang difference lang actually, yung dot sa Excel, tatanggalin nyo lang, diretso lang yun sa WPS Office. This is a special case wherein if the distribution is standard normal distribution, so no need to write 0 as the mean and 1 as the standard deviation, we can directly use this command. So, ang entry lang na gagamitin natin yung x tsaka yung true. And this is for computing the value of a, given that the area to the left side of it is given. And this is the special case wherein the distribution is standard normal. It means the mean is 0 and the standard deviation is 1. So that's all. Thank you for your time. I hope you learned something from this video lecture. Thank you.